Hi to all, welcome to my third class on chapter 6 triangles. In this class I am going to discuss converse of basic proportionality theorem and some questions from exercise 6.2. In the last class we discussed basic proportionality theorem. What is that? If a line drawn parallel to one side of a triangle to intersect the other two sides in distinct points, then the other two sides are divided in the same ratio. Now, let me take a triangle. Here you have triangle ABC and the measurements of AD, DB, AE, EC are given. And you can see here AD by DB is equal to 4.5 by 2.66, that is 1.69, and A by EC also 7.69 by 4.56, which is equal to 1.69. That means in this triangle AD by DB and AE by EC are equal. Now let me change the size. What will happen to the ratio, that is AD by DB and AE by EC? In all the cases you can see the ratios remaining same, that is 1.69. Now what about this line DE and BC? Let me draw a line through D and E and B and C. Let us see. Here you have a line through D and E and B and C. Now what about that line? Here you can see that line is not intersecting. That means these lines are parallel to each other. That is, if a line divides any two sides of a triangle in the same ratio, then that line will be parallel to the third side. This is the converse of basic proportionality theorem. So that we can state as, if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. Now look at the textbook exercise. Look at the first question. In figure 6.17, DE and BC are parallel. That is, DE parallel to BC. Find EC. Here you can apply basic proportionality theorem, that is AD by DB is equal to AE by EC. The measurements are given, so find out EC. Similarly, the next you have to find out the length of AD. Use basic proportionality theorem. Now look at the question number 2. E, F are points on side PQ and PR respectively of a triangle PQR. Draw a triangle PQR. Draw EF. Now the length of PE, EQ, PF, FR are given. You have to check whether EF is parallel to QR or not. That we already discussed. PE by EQ you find out. Similarly, PF by FR you find out. If both are equal, then you can say EF is parallel to QR by converse of basic proportionality theorem. Here is the third question. In figure 6.18, the figure is given. LM is parallel to CB and LN is parallel to CD. Prove that AM by AB is equal to AN by N. Here it is given that LM is parallel to CB. Now you have to check whether any triangle contains LM and CB. Here you can say LM and CB contained in triangle is triangle ABC. Now after finding triangle, now you can apply basic proportionality theorem as LM parallel to BC. So we can write, first you have to mention the triangle. So we can write in triangle ABC. Now LM is parallel to BC. So we can write LM parallel to CB as given. Then you apply basic proportionality theorem. That is AM by MB. You can write it as AL by LC. And this you can write the reason as since basic proportionality theorem. For every this type of questions, you have to mention the triangle, then the parallel lines, then basic proportionality theorem. Now here, what is the second condition given in this question? Ln parallel to CD. Now check the triangle having Ln and CD. Here the triangle having Ln and CD is ADC. Here Ln is parallel to CD. Now we can write, then what is the ratio? Start with the vertex A. So A N by ND, you can write it as AL by LC. Now the first ratio you can take it as equation number 1, and second ratio you can take it as equation number 2. In the both equations, what is the RHS? RHS you can see AL by LC, AL by LC. That means from equation 1 and 2 you can write AM by MB is equal to AN by ND. That is, for any two equations, if RHS are equal, LHS must be equal. So in this case, AM by MB is equal to AN by ND. But we have to prove AM by AB is equal to AN by AD. That means instead of MB, you have to write AD. How can it be? Now, let me take the reciprocal of these equations. That is AM by MB. Reciprocal is MB by AN. Similarly, which is equal to take the reciprocal of RHS also, that is ND by AN. Now, let me add 1 to both sides. What will you get? That is MB by AM plus 1 is equal to ND by AN plus 1. If you add 1 to both the sides, equation will not change. Now simplify it. That you can write it as MB plus AM cross multiply whole divided by A, which is equal to here ND plus AN whole divided by A. Now look at the figure. What is MB plus AM? That is MB plus AM. What is that? It is equal to AB. Similarly, ND plus AM. That is equal to AD. So this you can write it as MB plus AM. You can write it as AB by AM is equal to AD by A. Now take the reciprocal again, which implies you can write it as AM by AB is equal to AN by N. That we want to. Now look at the next question. In the figure, DE parallel to OQ and DF parallel to OR. Now you have to show that EF is parallel to QR. Now as in the previous case, take the triangle containing DE and OQ first. The triangle containing DE and OQ. What is the triangle? Yes, it is triangle PQO. So we can write in triangle PQO, QO, comma DE parallel to OQ. Therefore, the ratio you can write it as PE by EQ is equal to PD by D. And reason you can write since basic proportionality theorem. Now, what is the next condition? DF parallel to OR. That is DF and OR contained in triangle is PRO. So, write the basic proportionality theorem for triangle POR. That is, in triangle PRO, DF parallel to OR. Therefore, PF by FR is equal to PD by DF by basic proportionality theorem. Now, the first ratio you can take it as 1 and second ratio we can take it as 2. Now, from 1 and 2, what you can write? Here, both RHS is PD by DO, PD by DO. So, LHS must be equal. So, you can write from 1 and 2. You can write it as PE by EQ is equal to PF by FR. Now, what you have to prove, EF is parallel to QR. That is, EF is parallel to QR. What is the triangle containing EF and QR? That is triangle PQR. Now, if it is given PE by EQ and PF by FR are equal, then you can use converse of basic proportionality theorem. But here we proved it. That is PE by EQ is equal to PF by FR. So we can write in triangle PQR, PE by EQ is equal to PF by FR. So you can write EF parallel to QR, and the reason is by converse of basic proportionality theorem. Converse of basic proportionality theorem. In short, BPT you can write. So that question also solved. The remaining questions we can discuss in the next class. That is all for today's class. Have a nice day.